On April 19th, 2023, the world was awed and slightly alarmed by the news that a part of the sun had broken off. NASA's Solar Dynamics Observatory captured the event, and the images quickly went viral. The solar flare was estimated to be roughly the size of the state of Texas, and scientists were quick to point out that while it was not an immediate threat to Earth, it could still cause disruptions in our planet's magnetic field and communication systems. As we try to understand the implications of this rare event, we are left with a number of questions. What caused the solar flare to break off in the first place? How long will the effects of it last? What can we do to prepare for future solar events? In this video, we will get to the basics to discuss the facts that we have gathered from experts in the field to get some answers and shed some light on this fascinating event. Uncover more secrets of the universe by clicking like, subscribe, and hitting the bell icon so that you don't miss what we find next. This is Over Orbit Plus. The sun's activity and magnetic field are closely related and significantly impact our solar system. The sun's activity is characterized by the number of sunspots and solar flares that occur, which vary in intensity over time. This activity is driven by the sun's magnetic field, which is generated by the motion of electrically charged particles within the sun's interior. The sun's magnetic field is a complex and dynamic system with many different components and phenomena. The magnetic field is thought to be generated by a process known as the dynamo effect, which involves the motion of charged particles in the sun's interior. This effect generates electric currents, which in turn create the magnetic field. One of the most important features of the sun's magnetic field is the presence of magnetic regions known as sunspots. Sunspots are dark areas on the surface of the sun that are cooler than the surrounding regions. They are caused by the concentration of magnetic fields in these regions, which inhibit heat flow from the sun's interior to its surface. Sunspots are closely related to solar flares, which are bursts of energy that occur when the magnetic fields in these regions become unstable. The sun's magnetic field also plays a key role in forming solar prominences, which are huge arches of plasma extending out from the sun's surface. On August 31st, 2021, our sun put on a spectacular show that captured the attention of astronomers and space enthusiasts worldwide. A solar prominence eruption occurred on the surface of the sun, which released a coronal mass ejection, CME, directed toward Earth. You may wonder what this means and why it's such a big deal. Well, first of all, let's talk about what solar prominence is. A solar prominence is a large, bright feature that appears on the sun's surface. These prominences are caused by the sun's magnetic field, which can become twisted and tangled in certain areas. This twisting and tangling can cause a buildup of energy, which is released as a solar prominence. The solar prominence that occurred on August 31st was not ordinary. It was a massive eruption that released a significant amount of energy and material into space. This material, known as a coronal mass ejection, is a giant bubble of plasma that is ejected from the sun's corona at incredibly high speeds. What's fascinating about this particular event is that the CME was directed toward Earth. It could have caused a geomagnetic storm if it had hit us directly. A geomagnetic storm occurs when the CME interacts with the Earth's magnetic field, causing disturbances in the Earth's magnetosphere. These disturbances can cause power outages, disrupt satellite communications, and even create beautiful auroras in the night sky. Fortunately, the CME released on August 31st wasn't aimed directly at Earth, so the potential effects were minimized. However, events like this serve as a reminder of the power and unpredictability of our sun. The most significant concern with this event was the possibility of a solar tsunami hitting our planet. A solar tsunami is a phenomenon where a CME causes a wave-like disturbance in the sun's atmosphere that can travel across space and hit Earth. This wave can cause disturbances in Earth's magnetic field, leading to severe geomagnetic storms. The reason behind the recent event is still unknown, and more research is needed to understand its significance fully. Scientists are closely monitoring the sun's activity to understand how it affects Earth and predict potential hazards. It's worth noting that the recent event occurred during solar cycle 25, which began in late 2019. Solar cycles are approximately 11 years long and are characterized by the sun's activity, including the number of sunspots and solar flares. The current solar cycle has been relatively quiet compared to previous cycles marked by significant solar activity, including large solar flares and coronal mass ejections. However, the recent event shows that even during a relatively quiet cycle, the sun can still produce significant activity that can affect our planet. Just like we have weather forecasts for hurricanes and tornadoes, space weather forecasts help us prepare for the effects of solar storms. So how do scientists forecast space weather? They use various tools and techniques to monitor the activity of the sun and predict the likelihood and severity of geomagnetic storms. One key source of data is ground-based observatories. These observatories use telescopes and other instruments to monitor the sun's activity, such as sunspots and solar flares. By tracking changes in the sun's magnetic field, scientists can predict the likelihood of a geomagnetic storm. But ground-based observatories aren't the only source of data. Scientists also rely on space-based observatories, such as NASA's Solar Dynamics Observatory, SDO, and the ESA NASA Solar and Heliospheric Observatory, SOHO. These spacecraft provide a more detailed view of the sun's activity, allowing scientists to monitor the development of solar flares and coronal mass ejections, CMEs, in real time. Once scientists have collected this data, they use sophisticated computer models to predict the behavior of solar storms and their potential impacts on Earth. These models consider various factors, including the speed and direction of the solar storm, the strength of the Earth's magnetic field, and the location of power grids and other infrastructure that could be affected by the storm. But why is space weather forecasting so important? Well, the effects of geomagnetic storms can be far-reaching and potentially devastating. For example, a severe geomagnetic storm in 1859, known as the Carrington event, caused widespread disruption to telegraph systems and even sparked fires in some cases. If a similar event were to occur today, it could cause widespread blackouts and disrupt communication and transportation systems around the world. So by forecasting space weather, scientists can help governments and emergency responders prepare for the potential impacts of solar storms. This can include taking steps to protect power grids and other infrastructure, as well as warning astronauts and airline crews about potential radiation hazards. But while space weather forecasting has come a long way in recent years, there is much we still need to learn about the sun and its behavior. The recent solar prominence eruption on August 31st, 2021, was a reminder of just how much we have yet to learn. Despite decades of research, scientists still don't fully understand what causes these eruptions and how they relate to other solar activity forms. This is why continued research is so important. By studying the sun and its behavior, scientists can better understand how it affects our planet and how we can better prepare for potential impacts. This research is also crucial for developing new technologies that can help us predict and mitigate the effects of space weather. The recent solar prominence eruption and coronal mass ejection are just a small reminder of the incredible power of the sun. It's awe-inspiring to think that these massive events can travel millions of miles through space and potentially impact our planet. But even though we know a lot about the sun and how it works, there's still so much we need to learn. That's where ongoing research and exploration come in. Scientists use various tools and techniques to study the sun and its effects on our planet, from space-based observatories to ground-based telescopes. So, as we continue to explore and study the sun, let's remember to marvel at its power and complexity. And let's also take steps to protect ourselves and our technology from its potentially harmful effects. After all, we're just a small planet orbiting a giant, fascinating star in the vast expanse of space. It's a thrilling and humbling thought. Join us next time as we continue to uncover the mysteries of the cosmos. Like, subscribe, and turn on notifications so you don't miss a thing.